All right, so here's what we're going to be doing. We are going to be looking at a disk created by a curve. So I'm going to start really simple here. All right, here's a linear function. I'm going to call this linear function y equals, I'll do 2/3 x. Okay, that's just a linear function, y equals 2/3 x. It's got a point at the origin. It continues all the way through. And we are going to be rotating this linear function around, for this specific example, the x-axis. So we're going to be looking at this and we're going to say rotate y equals 2/3 x around the x-axis. And I'll bound this within the first quadrant. So that way we only have to consider the conical shape that would be formed within the first quadrant. So that specifically is that section of the line, that red colored in section. Now, that volume will be obviously in both the first and the fourth quadrants, because when you rotate this, when we actually take this line and spin it around, we are going to create a cone-like shape, because this line will basically be reflected across the x-axis to create shoop, 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 that cone. So always start with these steps. Sketch the region R to be revolved. Okay, so the region R to be revolved is this region formed right here. And label the boundaries. So within the first quadrant, I actually didn't set an ending point, so I'll go ahead and say x equals 0 and x equals, let's pick 5. All right, so that's where I'm going to begin at x equals 0, and this is where I'm going to end. I'll do x equals 5. So my cone will actually end right there when x equals 5. All right, sketch the solid generated by R. So this is going to require you to consider, what are these solids going to look like? Well, in this case, my solid will be a cone. It will look kind of like that. If you want to, draw some lines in it so that you have a general understanding of, okay, that's how it was rotated. It's got circles. Not perfect. But here's the key word here. When you are doing revolution, you are circling around something. So you need to consider that, hey, every time I rotate around, I'm creating circles within this figure. And every single circle has an area, and that area is determined by pi r squared, where that radius is nothing more than the y value. Because if you're rotating around the x-axis, the radius of each inner circle is literally this y value, this y height. And this y value, that y height, is created by 2/3 x for this specific example. So we can say that every single radius of every single circle can be determined by 2/3 x. That means that every single circle has the area of pi 2/3 x squared. So that's one single circle. But there are infinite circles all the way from 0 to 5. And the way that we find the sum of all those infinite circles, the accumulation of all those infinite circles, is we say integrate. Integrate from 0 to 5 the areas of all those circles. Pi r squared dx. So One thing that I want to make note of here, for statement number 4, use an integral to state the volume. The nice thing about volume is that it is always the accumulation of the area. So the volume of a shape is the accumulation of whatever those inner shapes are. So a revolution volume is the integral of all those areas of circles. So that's why we set it up like this. And then this is an integration problem. At this point, keep in mind pi is a coefficient. So it just pops out, and you leave these usually in terms of pi, 0 to 5. And then you do want to simplify this. So 4/9 x squared dx, which you can rewrite as 4/9 pi, because 4/9 is another coefficient, so it just comes out as well. Integral 0 to 5 x squared dx, and then we integrate x squared. 4/9 pi x cubed over 3 from 0 to 5, and then we plug in our endpoints. So we actually come up with a solid number to state the volume with. We say that the volume of that cone that we drew up at the top of the page, that's out of sight now, sorry, is 4/9 pi times 125, because that's 5 cubed, over 3. And if you wanted to simplify this, you absolutely can. Let's see, 4 times 25 is 100, and 4 times 100 is 400, so I believe that's 500 over 27, and we'll put pi next to it. So I'm going to stop this video here, and I'll pick up on the next example.